Welcome back to the Software Testing Journal podcast, where we explore the world of technology and quality assurance in today's rapidly changing software landscape. Today's episode is all about a topic that's become indispensable to modern development teams: continuous testing within CI/CD pipelines. Imagine a world where every single code change, no matter how small, is automatically verified for quality before it even gets close to your end users. That's what continuous testing promises, and we're here to unpack exactly how it works and why it's so essential.
Absolutely. When we talk about continuous testing, we're referring to the practice of integrating automated tests into every stage of your software delivery process. Instead of waiting until the very end of development to catch issues, continuous testing ensures that every code commit and every build is immediately checked. This means your team can catch bugs early, avoid costly production failures, and ship reliable software at an impressive pace. Think of it like having a digital quality control inspector working 24/7.
That's a great analogy. Imagine you're writing a document and you have a spell checker running in real time, highlighting errors as you type instead of appearing just at the end of your work. That's the essence of continuous testing. Every little typographical error, or in our case, every potential bug in the code, is caught immediately, giving developers instant feedback and reducing the risk of larger issues down the line.
And that immediate feedback is what underpins the entire CI/CD pipeline. To break it down, CI/CD stands for continuous integration and continuous delivery or deployment. In traditional approaches, code might be integrated and then tested much later, often causing knotted situations and frantic bug fixes. With CI/CD, however, every code commit triggers an automated process that runs tests, builds the application, integrates various parts, deploys to staging, and eventually moves to production after a series of validations.
Let's walk through that process step by step. It all starts when a developer commits some new code. That commit triggers the CI pipeline, which is the first leg of the journey. At this stage, the system kicks off a build and runs a suite of unit tests. Unit tests are small, individual tests that focus on checking the functionality of a single piece or module of code. They're designed to be fast so that developers get quick feedback on their latest changes.
Exactly. Once the unit tests pass, the code flows into integration testing. This step is crucial because it verifies that different components of the software work together harmoniously. No matter how well each individual part might perform on its own, problems can arise when the pieces interact. Integration tests help us catch these issues early before the software is deployed further down the pipeline.
After integration testing, the code is typically deployed to a staging environment. Here, a wider range of tests, such as UI tests, API tests, performance tests, and sometimes even security tests, are executed. The idea is to simulate a production-like scenario to ensure that all aspects of the application work as expected. And once those tests provide the green light, the code is pushed to production, where even smoke tests and monitoring can catch any lingering issues.
That comprehensive approach not only reduces risk, but also builds immense confidence in every change that's made. Now let's discuss the different types of tests you'll find in a continuous testing setup. We've already mentioned unit tests and integration tests, but there's more to the story.
For sure. In addition to unit and integration testing, there are functional tests which check entire workflows end to end, essentially verifying that the software does what it's supposed to do from the perspective of the end user. Another critical set of tests is regression tests, which confirm that new code changes haven't broken any existing functionality. And then there are smoke or sanity tests, which are a set of quick checks done immediately after deployment to ensure that the core functionalities of the application are working.
Let's not overlook performance and security testing either. Tools focused on performance, using technologies like Lighthouse, JMeter, or K6, simulate high traffic or intensive operations to ensure the system can handle real-world use. On the security side, tests using tools like SNCC or OWASP ZAP uncover vulnerabilities early so that potential exploits can be addressed before anything reaches production.
Moving on to the tools that power continuous testing, we encounter a variety of testing frameworks. For unit and API testing, popular choices include Junit, TestNG, and PyTest, each helping developers write and run tests efficiently. When it comes to UI and end-to-end testing, frameworks like Selenium, Cypress, and Playwright come into play, automating user interactions to verify that the system performs as intended.
And for API testing practices, tools such as Rest Assured, Postman, and Karate have proven their worth time and again. Many teams also use Cucumber for behavior-driven development, where tests are written in natural language. This BDD approach bridges the communication gap between technical teams and business stakeholders by framing tests in plain English, making collaboration much easier.
On the cicd front, Jenkins is perhaps the most well-known open-source tool used to orchestrate these processes. For projects hosted on GitHub, GitHub Actions offers an integrated solution that simplifies the automation process. Similarly, GitLab CI/CD, Circle CI, and Travis CI provide cloud-based options that further streamline the entire pipeline.
Beyond these, supporting tools that handle reporting and alerts are indispensable. Imagine viewing detailed dashboards from Allure or Extent reports that summarize all test results visually, or receiving immediate notifications via Slack or email when a test fails. These integrations keep the whole team on top of issues as soon as they arise, ensuring rapid response.
Let's talk about an example workflow to see how all these pieces interlock. Picture a developer pushing a code change into the repository. That push triggers a Jenkins job that begins by running the complete suite of unit tests. Once they pass, integration tests are set off, followed by deployment to the staging environment where comprehensive UI and API tests are executed. Finally, the test results are broadcasted through your preferred communication channels, and only then does the code find its way to production.
It's a beautifully tight process, and it underscores just how critical continuous testing is in modern software delivery. By integrating testing into every stage, from the moment a developer writes code until the application is deployed, you ensure that quality is maintained at every step, reducing downtime and customer-facing issues.
Now, when it comes to best practices for continuous testing, there are several guidelines worth noting. First and foremost, automate the right tests. Not every test scenario is suitable for automation. Prioritize those tests that provide rapid feedback, such as unit tests, regression tests, and smoke tests. Over time, this strategy helps maintain the overall efficiency of your pipeline.
Also, consider embracing a shift-left approach. This simply means starting testing as early as possible in the development lifecycle. When testers and developers collaborate from the design phase onward, issues can be identified and resolved sooner, which, beyond saving time, also leads to a more robust final product.
In addition, maintaining a fast feedback loop is critical. For continuous testing to be effective, tests must run quickly. Techniques like parallel execution or splitting tests across multiple environments can significantly reduce wait times, ensuring that developers are not left idle and that issues are flagged almost immediately.
Tagging and grouping tests by priority is another clever strategy. By assigning tags like at smoke, critical, or regression, you can easily choose which tests to run based on the context. Running fast, essential smoke tests on every commit allows you to catch glaring issues immediately, while more exhaustive regression suites can run in the background overnight.
Don't forget about managing test data and environments properly. Using mocks and stubs can isolate tests from external dependencies, while maintaining version-controlled test data, perhaps in JSON or YAML formats, ensures that tests run consistently across different environments. This ultimately leads to more reliable tests and faster debugging when issues do arise.
And finally, integrating your testing process with comprehensive reporting and alerting tools can make a significant difference. Pushing results to dashboards like Allure or Grafana, or sending out notifications via Slack or email ensures that everyone is aware of test outcomes. This visibility not only supports quicker resolutions, but also drives a culture of accountability among teams.
At this point, you might be wondering how all of these practices manifest in a real-world setting. Let's consider an example. An e-commerce platform that sees daily code commits from multiple teams, frequent changes in the user interface, and constant updates with new product information. In an environment like that, untested changes could have a major impact on customer experience and revenue.
In one case study from the industry, such a platform built a CI/CD pipeline using GitHub Actions. They automated around 90% of their unit and API tests. They also set up nightly regression runs in addition to smoke tests that were executed on every pull request. Complementing this with tools like Playwright for UI testing and Postman for APIs, the platform managed to reduce post-release bugs by a remarkable 60% within just 3 months.
That's a powerful demonstration of how continuous testing can transform not only the technical process, but also overall business outcomes. By identifying and resolving issues early in the development cycle, teams not only enhance software reliability, but also build customer trust and satisfaction.
Indeed, continuous testing isn't just about speed, it's about building a culture of quality. It signals a shift from reactive quality control to a proactive, constantly evolving process where every team member contributes to the overall health of the application.
Before we wrap up today's discussion, let's leave you with a bonus tip. Don't automate for the sake of automation. Focus on automating the tests that matter most to your process. Efficiency is not about quantity, but quality. Ensure that every automated test has a clear purpose and integrates well into your overall pipeline.
That's a perfect note to end on. To summarize our conversation today, continuous testing is a transformative approach that embeds automated checks throughout the software deployment process. It ensures that changes are continuously validated, thereby catching issues before they evolve into costly errors. From unit tests and integration tests to full-scale performance and security scans, every layer of testing builds a safety net that allows for agile, confident deployments.
And the key takeaway for our listeners is clear. Start small. Integrate a simple smoke test into your CI/CD pipeline and gradually expand your suite as you see the benefits. This isn't about trying to automate everything at once. It's about strategically placing tests where they make the most impact, then evolving your approach over time. With the variety of tools and best practices available, there's never been a better time to embrace continuous testing.
That's right. Whether you're a seasoned developer or new to the field, continuous testing offers a roadmap to higher quality software and more reliable releases. Remember, every test is a step toward ensuring that your software not only meets, but exceeds user expectations. Quality isn't an afterthought. It's woven into every line of code from start to finish.
Thank you for joining us on this extensive journey into the realm of continuous testing in CI/CD pipelines. We hope that the insights shared today give you both the inspiration and the tools you need to enhance your development process. Continuous testing is more than a technical tactic. It's a philosophy that, when embraced, can revolutionize the way you build and deploy software.
That's all for today's episode. We appreciate you tuning in and spending time with us as we explored the intricacies of modern DevOps practices. Stay curious, stay innovative, and let continuous testing guide you in delivering software with confidence and precision.
Before we sign off, let's do a quick recap in a natural way. Continuous testing is our spell checker for code, always on guard to catch errors early. It fits seamlessly into every stage of the CI/CD pipeline, from initial code commit to final production rollouts. The right mix of tools, from Jenkins and GitHub Actions to Selenium and Junit, along with best practices like shift-left testing, rapid feedback loops, and smart test prioritization, all work together to reduce risks and elevate quality. And remember, it's not about automating everything. It's about automating what counts the most.
Well said. With that, we thank you once again for being with us. We hope our discussion has sparked ideas for your own projects and that you'll feel empowered to adopt a continuous testing approach in your workflow. This is a call to action for every listener. Take that first step, experiment, refine your processes, and watch your quality soar.
Until next time, keep pushing the boundaries of what's possible through innovation and relentless testing. Thank you for listening, and have a wonderful day.